All right, in this video, I'm going to look at a weak-based strong acid titration. I'm not going through all the calculations, you know, save you the time of having to watch a 10, 15-minute video. So I just want to mention a couple things because you need to be sort of think about this process. The book doesn't go through a specific example either, because again, I think as long as we remember the steps, we can kind of get through these things. Obviously, the first type of calculation is not involving any volume of strong acid. So we're simply going to do an ice calculation. Working through there, that what we need to do, obviously we need to recognize we need to use a Kb value because we're talking about a base dissociating an equilibrium reaction. The second situation is we start adding um, a certain volume of the strong acid, and we now have a two-part problem here. The first thing you have to do is a stoichiometry problem. So what's going to happen is that base is going to be consumed by some of that acid. So what you're going to have in this example, ammonia is going to get consumed or react with the hydrogen ions from HCl or nitric acid or whatever, and we're going to make ammonium ions. So what we have to do is we have to subtract the millimoles that get consumed, just like we did on all the other examples. Once we do that, we've sort of reset our initial values, okay, our initial concentrations, and now we can go through our ice calculation. Now the problem is, at what point do we stop doing this in this order? Well, that gets to the point when we are at the equivalence point. And when do we know we're at the equivalence point? Well, when the millimoles of the weak base are equal to the millimoles of the strong acid. We now have reached that equivalence point. And when we've reached that equivalence point, we've got to pay close attention to the reaction. Okay? So what we would have here in this example is, once we have this reaction, what we end up having is sort of switching back over to the other reaction, meaning we're switching now to an acid reaction. All that ammonia has reacted with all that hydrogen ions. We now have ammonium. So now what's really going to happen is we have a certain amount of ammonium ions that are present because of all this that's happened back here, adding the strong acid. So now what happens is we have a certain amount of ammonium ions that are now going to start reacting with water and start to shift back to ammonia. Now, how much? Well, probably not very much at all. Okay? We're still going to have a significant pH because we've added acid, but now what we're trying to figure out is what is the exact amount that's left over. Okay? And the thing we've got to recognize here is, now that we're dealing with this reaction, we have now switched over to a Ka value. Okay? Again, I know this is the one that we'll have to work through transitioning to. The last one is, now we've just got excess strong acid, and that's the only thing that we're going to worry about, and that's the simply going to concentration of H plus straight to pH. Okay? Nothing special or extra we do there. We're already past the equivalence point. Okay? There's no base left over. We just simply calculate the pH given all our information. Okay? Now, dealing with these two things, two problems here I want you to kind of look at and work with each other a little bit. You have problems 55 and then problem 56. 55 is weak acid with strong base. 56 is strong acid with weak base. And what we want to look at here, I don't think we need to do part A because that's just simply equilibrium. So what we're going to look at is I'm going to have you look at B, C, and E. So B, C, and part E for each one of these. And go through that calculation, how you would set this up. Uh, do the calculation. I want you to check the solutions manual on Blackboard, okay, just to make sure that you understand kind of how they're setting up. And what we will do on Friday is we will kind of clear up some questions you have, things you don't understand, especially at the equivalence point, of that transition from one reaction to the next. And then from that, we should be able to, kind of move on. Okay. The last thing we'll just briefly talk about then would be acid-base indicators, and then we're out of acids and bases. And we can move on to the next topic. I know the acid-bases stuff so far, these last 3 sections has seemed to kind of drag on. I agree it has. So we're gonna clean this up and we're gonna start moving forward again. All right, that's it then.